This video is to do and explain question number 10 in the review sheet. In the review sheet, question number 10 asks you to find the null of A as a spanning set and then find a basis for the null of A. Now remember what null of A is. Null of A is set of all x in R4. You can see you need a 4-dimensional vector such that A times x is equal to 0. So instead of going with rref of A, we might need to solve this equation, and that is to do the rref of A augment with the 0 vector. Here is what A augment with the 0 vector look like. It's not just A, the matrix A, but you have to augment 0 0 0 there. Okay, so this augmented matrix represents an equation like this, and it's important because then we know about the system of equation. We don't just take rref of this. Now we take rref, and here is my rref using my TI-83 calculator. It looks like that. Remember, I want my rref to be always a fraction. Okay, if possible, write a fraction as a horizontal line, not slanted like this. So this is what the rref of A augment with 0 will look like. This will give us a system of equation. And if you are good, you know that x1, x2, x3, x4 are the variable. x1 is in terms of x4, x2 is in terms of x4, and x3 is 0, and x4 itself is the free variable. That will give us what the solution to this equation will be. So if you are fast with algebra, you can solve for x1, x2, x3, x4 very quickly as 10 over 7t, 2 over 7t, 0, and x4 is equal to t itself. So the solution must be a linear combination of that vector. That means if I were to write null of A, that means the solution of this equation, as a spanning set, it will be the span of this one single vector. But if you just want to be a little more fanciful, you can take out 1/7 out of every term and get a nice vector with integer coefficient. That is not necessary, but it just makes it nicer. So if I were to do that, I will get a nicer vector, easier to write. This is not necessary, but because of that, we know that the null of A is equal to the span of this one single vector. There you go. The span of this one single vector. And what would be the dimension of this subspace? This subspace is generated by only one single vector, and one vector is definitely linearly independent. So therefore, the dimension of the null of A is just equal to 1.